We got a new one. 201 TC. And reporting. I don't actually do much reporting on these. I do a little. I'll go over it as I go through it. But we also do these a little cheaper. So here we go. Gotta be extra careful. These tiny rings are easy to break. The 200, I've done by far more 200s I've ever done of these, but the 200 is a better made saw, better design saw. Shouldn't say better made, better design saw. These are just stupid. This is the latest version. And the early version of the 201s wasn't too bad, but this silly disaster is a very weird shaped combustion chamber, and it literally doesn't have any squish band to speak of, and what's there is on an angle in a stepped silliness. I'll show that a little closer. Makes it very difficult to lower the cylinder or do any work on it. I got around it, but it's just dumb. This stupid thing doesn't need to be on there either. That's just dumb. So we cut the base, we drop the cylinder. I may cut the base just slightly so I can get rid of this, or I can just grind this off. Do a little raise in here. Get the feet a little better. I might do a little intake port timing on it. But as far as like doing transfers or the exhaust timing, you know, a little cleanup maybe, but I'm not really concerned about changing a port timing on it. I'm doing a gasket delete basically, and the squish will interfere just on a gasket delete. It'll hit. So I made a cutter kind of specifically to fix this, and the way they do this piston is just stupid. It really truly is. So I think they want to keep people out of it, but it will never run. I don't believe they'll ever run quite like a 200. Just simply because of that combustion chamber design. It just doesn't make sense. But that's the teardown. That's where we're at, and we'll continue on from there. I'll give you some close-ups on this stuff. You see all the different steps in there? What do we got? Right on the edge, we got like a 75 thousandths of a flat spot. Then we got a weird angle. And then we got a chamber, right? And that odd angled part is, you know, quite a bit to it. And a piston, that angled part is very short, right? And we got a little flat spot out here on the edge. Right? Put a little flat spot here. And then this raised angled thing. Right? And this is supposed to match, you know, the angle in the combustion chamber. But that combustion chamber is probably, you know, comes in probably this far. It's a small diameter combustion chamber up in the top of that piston from that really wide angled, I don't know what you'd even call that, you know, but the squish band is like almost nothing. It's just a little narrow, you know, but all this baloney has got to be in there. Makes for a frustrating combustion chamber to work on. But I do have a fix. I do have a way around it. I do get around it. I do like to get rid of this. This sticks down, way down into the case, and just about all it does is makes them tunnels longer. And I'd rather reduce the length of the tunnel. It changes basically changes the timing of the fresh air charge, right? Air fuel charge gets it there sooner. So I do some exhaust port work as far as the flange goes and the tunnel, but I don't really change the port window. It ain't bad for port timing, and I don't do the transfers. It's really hard to get in these tiny little cylinders to do any real good. And everything is so small, compared to my thumb. Everything is small, tiny, and hard to work with. So I do what works for me. I just don't do it all like I would a bigger saw. And this thing is a top handle tree service guy, and we don't need a crazy saw up there that a guy's going to run with one hand. I'm not saying he's supposed to, but he's going to. So anyways, that's where we're at. We'll move on, and I'll show you some of the tools as we go. Put the cylinder back on the 200. Put the gasket back in. I left the rings out. I put the gasket back in. I put the cylinder back on. The reason I did that is because without the gasket, I just set the cylinder on there. I couldn't turn the motor over. So I want to go back and I want to check the squish as it was stock. First thing I want to do. So that's why I put the cylinder back on. Put the gasket. Need to know where I'm at. I really don't like this design at all of this thing. It's kind of strange. Crown of the piston and stuff is kind of strange, I really can't feel that, but I can see, it just flattened out the very end, primarily right at the end. It's got that silly step in there, It'd be about impossible to measure this right at the very end, but I have to decipher what part of that piston is tight. Is it that little flat spot on the edge or that tapered angle part? So I got to measure this like right on the edge, And if I got more than the thickness of the gasket, I got to figure out where it's hitting, because I think that's going to be the case. So right on the edge I have 20. I go up just a little bit, so I'm on that tapered area, I have 22. I don't believe that that gasket is 20 thousandths. I don't believe so. $17. So I'll leave the gasket off now. I put the cylinder back on. I don't have to bolt it down. But it's heading. You can hear it, right? Bang, 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 bang. Lifting it up, setting it back down without bolting it down. And I can screw the bolts down. I can turn it fast, but it's hitting. Right? I don't see anything in there. I see a little booger right here in the piston though. Like there's something there, something on it, or yeah, a little piece of something there. Metal looking. Little bump, little tiny, tiny, tiny. Nothing that's going to affect anything. But is that what it was? No. It still touches it somewhere. And it's really hard to decipher, you know. What's hitting? Where's it hitting? Why is it hitting? It shouldn't be touching, but then again, as I've stated in the past, that solder's not perfect. So now what I've done is forced it over on my solder, squished the solder way out, and now if I look at the solder, I can look at the width of it, right? And the further it squeezes it out, the center it is. Oh, can you see how it almost looks like a triangle? Right? So it's like this, right? So it's tightest right at the very edge. That's what that shows me. Alright, I got interrupted. Rear check and squish without a gasket. Determine what the tightest part was. Determine that was the little short flat. So that'll be the first thing I got to cut first, is that. But I'll get rid of this silly thing on here. I'm going to be raising this port up as well, I believe. So by getting rid of this, it allows the fresh air fuel charge. See, this is a straddle motor. It's less fresh air in the transfer ports, and the fresh air fuel charge can get up to the combustion chamber quicker. So it sort of kind of changes the timing of the straddle if you get rid of all of this and raise the lowers up. So that's the first step. That's what I'm going to do next. And then I got a specialized cutter. It's 2 steps, but that I made just for this cylinder. And I can cut the flat and I can cut the angle. And that'll be after that. So that's next in the process. I'm not going to show absolutely all of this work, but you guys get the idea. I'm just going to cut this thing off. No big deal. Grind it off and make sure that it's just, you know, a few thousand slower than the rest of the cylinder. And then I'll show you my setup on the mandrel. Kind of a specialized mandrel. I got an extra angled piece in there for the cutter, and then where the cutter is now, I'll do the flat. So it's kind of a 2-step deal. I'll move the cutter from one spot to another, and that's how we make that work. So, but this thing's in my way no matter what, and I don't want it on there anyway. So that's next, and we'll be moving on. Cutting the cutter set up. I'm just going to try cutting it right here. It's so narrow, I don't think I need to put this in the vise. For the flat anyway. Now I could take this piston off and I could put it in the lathe and I could cut that little angle and follow that angle off and get rid of that little flat ledge. And that would be an easy way for me to do this, and then just cut the angle in the squish band and be done with it, right? But then when it goes to change piston someday, possibility, that nothing works, nothing fits, nothing's right, and then they got to deal with it. And it's always been my motto to try to leave the piston stock if possible. Do all the work on the cylinder. That way, if a piston does need to be replaced, it's no big deal. So I try to do things right. I try to think of the customer down the road, all that kind of stuff. We're looking to get about, you know, 20 thousandths or something, you know. Such a small saw. Probably be just fine at 15, maybe even a little less, but we certainly ain't gonna gain much with this. No, it's not like I'm able to raise the compression a bunch. It's basically just a gasket delete, you know. Changes the port timing a little bit, which I always felt was good on these, so and then a slight bump in compression, you know. And seeing I gotta do this in 2 stages, it's kind of hard to do. Trying to hit, you know, those exact numbers, because I kind of gotta squeeze it pretty tight. All I'm trying to do is check the flat, but the taper is still tight, right? So it might give me a little false reading. I might have to do a little back and forth on the cutter, but takes a little extra time, but I prefer to try to do things correct. Now when you look at it, you know, it's not so much of a triangle, it's more of a belly and a, you know. So again, I got to measure right down there on the tip. That's where the flat's at. That's what I'm working on. I have 15. Like I said, that's probably good enough on such a small saw. There ain't much heat expansion on anything to cause it to be a interference problem. I like 20. I like to stick with what I do, you know. It measured around 20 stock. Oh, not bad, you know. A lot tighter than they used to be, you know. We used to be able to pull a base gasket and call it a day because it still wouldn't even be close. I get 18, 19, I'll probably quit there. I don't see a reason to go any further than that. That's 18, 18 and a half, 18 and a half. I'll call it good there. I cut the end of that off now, you know, and I can measure that taper because that's on there. Cut as much off as the flat spot is. Measure the taper, we're at 15. Take my cutter out. Can't see what I'm doing. Take my cutter out of the flat. Put it over here. Cut the angle. I'll draw it anyway, huh? Need to come up with a different style screw. I threaded that. I threaded a little bit in the wrong spot for a screw. Someday I'll have to do something a little bit different with it. I don't foresee doing a lot of these, but that looks even all the way. Cut the flat end off where it's flat. So we're just measuring the taper because we already set the flat. $15. I'm sure a lot of guys out there would do something completely different than this. That's fine. I just like to have as many of my saws as possible. You know, a simple piston swap if needed, you know, just put a new piston in and call it a day and not have to do a bunch of machining or screwing around to make it work, you know. Save the next guy a little trouble, you know. I don't need to do a fast, easy, dirty to make money. You know, I'm trying to do things right, not get rich quick. Not my thing. To 18. We'll call that good. Took me a little while to do that, you know, but it takes me longer to do, when I do a full squish band cut, it takes me longer than that. So it's not that big a deal, you know. It's not that big a gain as far as port timing or compression. I've done these saws both ways and I feel it's worth the time, so that's why I do it. You know, like I said, I don't do things for no reason, so if I feel it works, it works, and I do it, and you know, somebody's got a better idea, I listen, but I don't know, not too many people talk me into changing my ways. A few, you know, I mean, there's guys out there that's got some good ideas. All right, we're going to look at the port numbers, and just to make sure I don't want to lengthen the intake or something, we'll check all that out. I'll set up for doing that, and I'll grab the numbers, and then we're going to make some modifications to the exhaust side of it. Open this stock muffler up a bit, and carburetor, of course, and let's see if I want to lengthen my intake duration. I won't be changing exhaust at all, other than the tunnel flange out. I'll increase that a little bit. These don't have a gasket. They just got kind of a funky little thing that folds inside the port. I cut all that out of there, but there's no gasket for these. They might leak a little, weep a little, but eventually they'll carbon shut, so they won't leak forever. And I could put a little sealer on there if I wanted to, but that burns off fairly quick, and maybe some high temp stuff or something, you know, might help a little, but not a lot. Anyways, that's where we're at. On to the next one. All right, we got a few things going on here. What we're gonna do, and it doesn't have very much intake timing at all, right? And you know, normally these would be cut flat. They put this funny little notch in there. Right? Center of the intake port. There's a little flat that shows on each side of the port, right? And if you go off of the flat, it's got like 140 degrees duration. If you go off at the peak of this notch, it's got about 154 degrees of duration. So I'm gonna square this off so that it's an even number, right? It's all at one time. It's not this funny shape where it opens a little and then a lot. We're gonna square that off to be somewhere around that 154.5 range. And then I'll decide if I want more. I might want to go to like 160. Probably wouldn't go over that, but about 160. The reason being, this is the intake boot. That's just the number 2 pencil. It just barely fits in there. And if you look at the crankcase, it's a fairly large case for the size of the saw, right? And there's some garbage in here, some weird things in this intake boot and track, and you know, from this end, you know, the pencil really doesn't even fit in there. You're forcing it in, and it's distorting the boot. So you know, it's you know, like the size of a pencil basically when you take and count the rest of the shape, right? That's about all it is. And the fresh air charge is even smaller, right? And when you look through there, everything is crooked and bendy, and it's got them little bumps in there and all that kind of stuff. And a fairly large crankcase volume, and we want to try to fill that crankcase. So I feel we need to give the, you know, the port a little bit more time to fill. And I'd rather get more fresh air charge in there than just fresh air. So we do enhance the fresh air side of it. But if I can enhance the air fuel charge more, I'll do that, you know. And I can do that by increasing the timing. Try to get a little more flow through it. Very small carburetor, very small everything. So then, you know, everything's tiny, right? So the next thing is that if you look at the base gasket matches the case, right? And you can see that, you know, this flange, when I cut this flange off, that it's nowhere near as big as the case. Ideally, I would like to split the case and epoxy up the side and back of that case and match what I do to the cylinder. I'm not going to go through all that because I try to keep these at a little better price. But ideally, that's what I should do. I can make the case volume smaller by doing that. I'm just going to kind of chamfer around over all these corners, right? That's about all I'm going to do with that. If I was going to match it, I want this flat, right? So, and then I stuck a ring down in the cylinders, down in there. And I set the bottom edge of the ring to the top edge of the transfers. As close as I can with this taper on this piston, right? I slid that down in there, right? I can raise the lowers, I can raise this up to the bottom of the piston. And I put a red Sharpie mark in there. It's in there. So I'll be raising this. I'll be rounding all these edges on the side and the back. And raising the front edge of it. Feed them transfers better, sooner, faster. And get more of the fresh air charge up there sooner, quicker. This allows me to advance my ignition timing further if I want to, because we don't have that lingering fresh air that kind of creates a misfire if it doesn't have time to mix if you run your ignition timing too far advanced, they'll get a miss. And that's basically with stratified motors. And I think that's why it does that. It's too much fresh air charge in the combustion chamber at high RPM, and it hasn't mixed that fuel and fresh air charge in there, and it creates a misfire. That the air fuel ratio is too lean to fire, I believe. And I could be wrong, but I believe that's what causes that. Because pretty much you only see it on strato motors. Don't really see that in a conventional motor very often. Sometimes it's a weak coil and you can actually see the spark miss from a weak coil. Or it's a rev limited coil, which is a miss. But the two sound a little bit different. So anyways, that's what we're going to do. Then we're going to open up the exhaust flange here a little bit. Get a little bit better flow. We're not changing the port window. We're not changing the transfer ports windows at all. We'll feed them a little bit better. And then I'll see where the piston lands for my intake port. And I may do a little lowering of the intake port at the window. On the intake port. We'll see where it all lands when I get that far. We got about 13 degrees of blowdown and 141, 42 degrees of exhaust duration. So that's what we got there. Everything's going to work out fine. And tiny saw, tiny everything. We don't need no great big high numbers. We're just trying to get more fuel in it faster. It'll help it turn a little higher RPM. And for what the saw is actually designed to do, pruning and trimming, the RPM is fine. We shouldn't lose any torque because we haven't done anything to lose torque. So we should gain a little bit on the compression. Everything else is left as it was. So hopefully we're gaining a little RPM, push the torque curve up a little higher, and they usually turn out to be a pretty good top handle climber saw. That's what this saw is going to be used for, guy's climber. So you like the last one? I think you'll like this one. We're doing basically the identical thing that we done in the last one. So but I might give this one just a little bit more intake than the last one, and see how that works out. So that's what we're going to do. One piece at a time. Something like that on the piston. Don't want to get over here into this port with it, you know. You want to leave a little something on these edges to seal, right? Doesn't have to be any wider than the port in the cylinder, and I know that's wider than the port in the cylinder, and that's good enough. We got that taken care of. At least on the piston. I'm going to work on rounding these edges off on here and raising that up. I can't do, you know, and there is near as much work down in here as I'd like to do, because these side transfer covers are glued on, but it's not just a cover. It has pieces that go in, like the transfer port is, fully encased in that cover. It goes all the way almost right to the cylinder wall. The piece in the back here comes all the way up. You can see it right there. It comes all the way in, into that port. And, none of them edges match very well at all. And even in the transfer port, none of it matches very well at all. In my mind, piss poor design. They could do better than this if they wanted to. Steel branded cylinder, no other name on it. Don't know much about them. Don't know where they're made, anything like that. But it's, performance wise, nothing spectacular here to look at. But that's about what I do. That's what they look like. And it gets the air fuel charge through there quicker and less fresh air. Well, I shouldn't say less fresh air in the system, but it would be, because the excess, I guess would be the word, of fresh air that comes in is going to get mixed in the bottom with the air fuel mixture that's down there. So there's less in the transfer ports this way on the stratified side of things. So I think that's pretty much about all I can do to, try to feed this thing better. Of course, the next thing would be to start, changing the transfers, but you can't because of this plate thing. You could shave just a slight amount out of there, but not very much. And I'd rather not create an air leak because we ground through that thin plate. So we're not going to do that. We leave everything as it is, and a little exhaust work, get the exhaust out as fast as we can so we can get as much in as we can. More duration on the intake. Fill that crankcase up, get as much in there as we can. I might even check the stratos by using air and kind of get an idea of where they're at. If I really wanted to, I could probably change the strato timing a little as well, because the more air you can get in it, all you're doing is adding fuel. The fuel is easy to add. You need to get the air through the motor to make the improvement. So even though it's fresh air, it still mixes in with the rest, helps flush out the old charge batter, all that kind of stuff. So it's not something that I do that I'm negative about, but I generally don't change strato timing at all. So one little hiccup here I got to take care of, and then we're going to move on to something else here. And of course I got a chamfer of it. Rounding that edge is better than leaving it square. See, I'm not doing crankcase work. Otherwise, I'd have left this edge square, not rounded it off. You know, if I was going to fill a crankcase, I'd want that to be a nice, you know, flat to flat surface, you know. But I'm not going to go through all of that for this. I don't know. It's really hard to get enough fuel into these motors. Just because of the tiny carburetor, tiny ports, tiny everything. And all we can do is give it a bunch of duration and try to give it as much time as we can to get something in there, you know. So if I were to have some running issues with, you know, let's say some kind of running issues, and it's because that I have way too much intake duration and not enough strato duration, I can always come back and give it a little more strato duration to try to overcome that. But it shouldn't be a problem, truly. So, all right, let's work on that exhaust port a little bit. So I had a ridge all the way around it from the way the muffler's made. You know, it's got a little lip that fits inside. I'm going to take the lip off from the muffler, eliminate that, and that's about what I opened this up, right, to. And that's about what I'll open, just take the lip off, and that way it'll match. I don't have any gasket or anything to port match this, and I don't want to create anything. So that's how I do it. I just don't go overboard. I take that lip off a little bit more. That's what I took out of here. That makes this a little bit more freer flowing. And that's about all I'm going to do. I could probably widen this port just slightly, but I don't feel it's necessary. So we just open it up, get the exhaust out of there as fast as we can, and call it a day there. So nothing cut off the base. Open up the lowers. Open up the exhaust a little bit, make that a little more freer flowing. We changed the intake duration already on the piston, and I may change it a little bit more here. I want to see where I'm at when I put it all back together here, and we'll check our durations again. I put the piston back on and that kind of stuff. So that's where we're at. If I like all of that, this cylinder's done. If I want to change the duration on the intake, I'll do that. There ain't a whole lot to do in that. It's just a little tiny hole in there, right? So, all right, on to the next one. All right, decided to leave the intake where it was. I liked it. For about 156 or so. The straddle opens about 8 degrees after the intake port opens. So that's fine, you know. We can live with that. We could change that straddle porting some. We could narrow that up, get that down to 4 degrees or something maybe, but we don't need to push a climber saw. Not in my mind anyway. Give it a little extra and call it good. We're going to start putting it back together. I put the rings on. I still got the degree wheel on it because I'm going to mark my timing. Once I put cylinder on, I'll mark my timing on the flywheel. And I want to change it. Probably 8 degrees. And then I can get rid of that. Put as much together as I can. I still got to do the muffler and the carburetor. But we can start with this much and at least start getting things going together. like to put my timing mark somewhere around bottom dead center. That way I can put a rope in here, I can pull the flywheel, I can adjust everything. I don't need to pull the rope out, it won't be in my way. I can adjust my degrees I'm looking for, my timing I'm looking for, and I never have to pull a rope. So that's why I do it kind of towards bottom dead center. And it doesn't matter where you put the mark. We got a point there. So 8 degrees. Put a mark there. And that's done. Then we're pretty much ready to start sticking things back together. We got to do the muffler first, get it on there, and we can have some room to be putting some other parts and pieces on there. The muffler on it, and then we can start putting bigger pieces on it. Got to do the muffler next. All right, we're gonna get after the muffler here. Like I said, this got that little bridge that goes inside in the port. We're gonna cut that out as big as that, just slightly bigger, so that we basically have it port matched best we can. And then stock opening is going to be made bigger. It's double layered in here. Part of that double layer will be coming out of there. It always does, but I enlarged that stock port. It's quite small. And pretty much all I do with the mufflers. They're just an empty open can anyway, so a fair amount of volume really for as thin as it is. difficult muffler to work on. About it for the muffler. Got the carburetor here. You know, these split small carburetors like this on these small saws, If you look at the percentage size of that shaft, of how much that blocks off that carburetor, opening these up makes a big difference. So, the smaller the carburetor, the more gains you get from doing this than in shafts. The harder they are to do too. I'll have to just grind some off the head of the screw, because that ends up being on the fuel side of it. Give that just a little extra on the fuel side. The choke side of it's not so important, but the throttle side is always smaller. So, you know, I'm looking at that size there, and I have to do that. The only downfall with this is if you ever wanted to take the shutter out, you'd have to, you know, remove the screw somehow. So chances are you'd have to cut the shaft on each side and, you know, wiggle everything apart and put in a new shaft, screw and shutter. But when's the last time anybody's done that? You know? So we're good with that. So we can start putting things back together. Alright, we'll continue on putting it together. that back off. Get ahead of myself. All right, what's next? I get the impulse line on first, and then we gotta get the boot in there. Take vent back in place. That fuel line is here. AC on there, and I already done the ignition timing. At about 8 degrees. Filed the key. Hit it off camera. Nothing big and exciting there. Hardest part of the whole thing is the carburetor. Kind of a pain in the ass to get it back in there. Get everything hooked back up to it. Not too many places to put stickers on these. Alright, that's it for this one. It'll be taken out and run. I'll put that on the video. The next one.